Thank you. I assume you can hear me. If you saw my introduction to this, I said that in a real world, we don't have the time to actually refactor all our application and rewrite everything into dynamic functions. And we're kind of like stuck with design decisions. Some of this is more than 25 years old. And we still have to kind of like perform within these areas. So this is what I'm going to talk about. SimCorp Dimension is a monolithic application, meaning that's one APL workspace. And this is, what I'm going to talk about today is actually something I think most of you guys can directly go home and adapt within half a day. And hopefully you see the benefit of this. So this is my agenda for today. I will talk a little about ideal world and reality. And actually, I'm not going to talk about the ideal world. I'm going to talk a lot about reality in SimCorp Dimension. Then I'm going to revisit the isolation futures, and I think this is going to be the last talk, at least from SimCorp's side, on the model of isolation futures until this is going into the real interpreter, or something like that, Morten. Then I'm going to do a sketch of the solution, and that's my picture show. So if the internet goes down, you at least have the picture show of what's going on. And then I'm going to do the daring live demo of this. And then I'll have a final slide about, wouldn't it be nice if... Okay. Raise your hands. How many of you have code that's been running for 25 years? A lot of people, right? In that case, some of you guys will recognize the second line, namely that we have 100% traditional functions. We don't have dynamic functions. This is the world we're living in. I mean, we have to work within these boundaries. A total rewrite of functionality would probably not be done in APL. Hopefully, it will be done in APL, but I mean. The world is changing, and new programming languages comes into this, and if we have to rewrite major parts of this, then there will be strong things that would say it could be done in a different language by APL. It's easier to recruit people from outside in other programming languages, maybe, maybe not. But that's not my point, but it's just a rewrite has to be something you do as the very last thing. Okay, we don't have, of course, we have coding standards, so Aaron will hate us, and we have states, and we have caches all over, and we call QuadNA our financial library is written in C++, and we talk to the Oracle database via QuadNA. We have .NET as an integral part of it. We also have a big .NET application that talks together with SimCorp Dimension. We do have load balancing, which is kind of like a parallel stuff, but that is running in the basements of the global IT departments, and it requires quite a lot of infrastructure and moving parts being up. So we can use it, and this is what we're using in production right now, but it would be nice if the scalability were much closer to the developer than rather being standing in the basement. And then we have this, that every time we start up the application, it takes 10 plus seconds. I will save you for the startup time today, I think, but it's very painful. I mean, we have developers, also developers sitting here in the room that complains about this all the time. So this is the reality for SimCorp Dimension. Some of this, is that totally different from your applications? No. This one, of course, but that's kind of like, that's also a political statement that you also cost benefit of stuff, right? Okay, let's go on. You've seen this one in different paintings a number of times. I mean, we have this Dyalog workspace, huge, big workspace, and then we have these tiny isolates that can do well-defined, super fast APL operations. Steve has this is the reality we're looking at, right? This is SimCorp Dimension, right? And if we have to do something, we need SimCorp Dimension. So this is our Mickey Mouse version of the reality. And this is what I'm going to demonstrate now. This is what's been implemented. And I should actually credit Morten to this, because when we started working on this, it was I called him and I said, I'm trying to get these isolated futures working. And then he came visit us and we tested stuff and he built something for me and then said, nah, we're going to do it in a different way. So this is done in a different way. Sketch of my solution. I had some objectives for this. I don't want to have any installations of any new softwares on my developer-application users. This should just be running as anything else. It should gain some kind of scales in number of CPUs. Actually, I was thinking about giving the title to this presentation and being the frustration over the green fish tank. Most modern computers have 8 CPUs, and when you're running one application in Dyalog APL, you see one of these fish tanks filling. All the rest of them is just empty, nothing's going on. So we need to have some kind of scaling in the CPUs. And I think what is important here, when we see Aaron and when we see Martin's presentations here, we talk about executing fast APL, which is okay. But I think the reality we've come to see is that we don't have a lot of stuff that takes a long time in APL. There's a lot of small steps that add incremental steps, but then suddenly you're out calling the financial library, and then you need to get data from a database, and then you're doing something else. So for me, it's about performance. It's more like executing stuff in parallel. But we also know that the ampersand, which is kind of like the spawn operator in Dyalog APL, only have switch pointers at very limited places. So unless you're good at actually making your code so you can hit these switch points, you will not get parallel execution. So you will not fill up the fish tank. Did that make sense? Okay, we've got coding standards, Aaron, and we love them. I mean, being 200 plus developers requires coding standard no matter what you do. And it also, we've talked about this a number of times, we're enforcing our code standards before check-in. So if you don't comply to the code standards, your code don't go in. And then the solution should have low maintenance. This is kind of like the implementation, the overall idea for the implementation. I say implement a class-like constructor for these Mickey Mouse outside stars. I need to work some way out how to get the minimum startup time. I still need to do some startup time. The technology we're basing this on is external shared code pages. How many have tried using them? Yeah, exactly. I will tell a little bit about this in presentation. Conga, which is known Dyalog remote procedure called the workspace in a slightly modified version, but Morten used that on Sunday, I know. And this new class called APL processes. And then you need to have a dispatcher. You need to be able to distribute your arguments and then consume them in a load balancing style of way. So this is the solution. So now we're going to go to the picture show. This is SimCorp Dimension Workspace. Replace SimCorp Dimension with your application, because I think every one of you have an application look like that. And in this workspace, you have a red area which contains function, global variables, static caches, namespaces, classes, you name it. If you need to do the full SimCorp Dimension, this one here is 300 megabytes. We have always done what we would call a file server installation. That means we require a pretty fast network if we have to transfer these in due time. The first thing we did was we implemented, or this is of course triggered by us, but we needed a way to say, okay, can we get these static I mean, functions are static, right? We don't modify functions on runtime. We have a ton of global variables. We don't modify them on. It's kind of like constants, but there is no such thing as a constant in Dyalog APL, but they're constant in our mindset. And some caches that can be initialized and then moved out. So this yellow one here is what is called a shared code page. You can think about it as a DLL. So it's loaded once by one process, and all the other processes that attaches to this file will just get it. So this one is transported from the file server to your local machine just once. And of course it's versioned, and it has to be in the right configuration with your system and all this. And then you attach to it with the infamous IBM 866 number for the devil, I assume it is. Yeah. So it is in principle what you do. So what you can do is you can have an empty workspace here, and what you do in your quad LX is you say 866 and then name your code file, and then your workspace will be filled. The effect of this is that, it's really pretty hard to see here. I just had to demonstrate I could write one line as an APL, but this says that the number of objects, after you've done this shared code page attachment, the number of objects is unchanged. The quad VA is bigger. You can see that here, right? Because the red dot here, which is kind of like the stuff we couldn't move to the code page, is much smaller than it was on the previous page. So your working area is much bigger. Number of compaction and all this will probably go down. And then there is this disclaimer that the first call is slightly slower, and that has to do that for some internal Dyalog reasons, stuff is moved from the shared code base to the workspace, but we haven't been able to actually measure this at least not in version 15. Version 16 is a different story. We'll talk about that another time. Okay. So now we have SimCorp Dimension. This is SimCorp Dimension. It's running just as it's been doing all the time, and now we're going to try to do some work here. So we copy in the APL process from an external workspace, and we start it up. And this workspace has a different color because this is not SimCorp Dimension workspace. It's a tiny little workspace, of course with workspace available, but it doesn't contain any functionality apart from the ability to talk with Conga. This is Dyalog provided code. So you establish a Conga communication between those two. And then you inject, because this workspace is kind of stupid, right? It doesn't know anything about SimCorp Dimension. So you inject what is needed from you, what is needed for you to start up. You inject code from here in here, and then execute it. And then you attach to the shared code file, because that's probably the first thing, or this is actually the first thing you do. You attach to the shared code file, because then you have all the functionality of SimCorp Dimension in your blue workspace, even though it's not a SimCorp Dimension workspace. And then you repeat a reasonable number of times, which is like CPUs -1. It could also be CPU times 2 -1. You have to experiment a little bit about this, and then you start. And then I'm going to talk about this function. It's called dbSelect. This is our database interface function. Given some arguments, then you're going to call getting data from different tables. So I have a number of arguments here, and I have a niche. You'll never see that code in our production, but it's easy for me to demonstrate. And it's also kind of like pinpoints my idea that all APLs will say that Oracle are notoriously slow, right? So, but we don't have a switch point here. So we will have to wait for every single database call. Whereas if we could do like this, and I know more bright APL programmers can write a different operator that can do this. At least I know one of us in the room has done that already. But I'm not in that sense so special about this. And so what I did is, you saw I replaced the each here. It was an each here. And then this is the same function, right? And you execute. And then, because you only have 7 here and you might have 100 arguments, then as soon as the first one terminates, it says n+1 down here now. As soon as the first one terminates, it'll go out and investigate the queue. Is there more I need to process? And then this will actually return at the end with all the results for all the n arguments. So, inject a fast function in here, connect to your code page, call parallel execute, and you're into business. And there is, of course, this injecting your startup function. You have to know what you're seeing your quad LX now for your application. But apart from that, I think this is applicable for all applications that has just one workspace. Okay. How are we on time, Morten? Excellent. So I'm going to do my live demo now, which is kind of like crazy, but I'm going to do it anyway. DB select ttrans main, our transaction table. Count how many rows there is in this one here. So this is like my overall example in this. So I'm going to say, okay, let's enable our parallel stuff. But that was, and it's kind of like cheating, because the first thing that happens is just spawns all the workspaces. There's 7 here. I have 8 processes on my machine. And then it calls the init function. But you saw that was okay, right? It will take 14 seconds roughly here for this to start 7 extra processes. You can do that somewhere in the application before you start. And then you're going to do, we have 3,500 tables in our system, if not 4,500, I can't remember anymore. So now I'm going to make an argument that says, let's count the number of rows in the first 100 of tables. So this is just db select trans main, but just now on 100 tables. And because both Oracle and we have caches here, I'm going to call this more than once, just to kind of like getting the caches warmed up. So if I'm doing it in the sequential word, I don't know if this is a common way of doing it, but this is kind of like this. This is quote account information. This is the CPU time used, and this is the real time used for a given call here. So if I call it in the sequential way, this will take 1485 milliseconds. If I do it in the parallel version, it'll take 341. And the only thing I did was I started all of these, right? And then I called the same function. It is the same function per definition. And there's not a lot of APL in these. Actually, there's hardly any APL in this call. But it still gives me a benefit of a factor of, if we are positive 4, but at least 3.5. And then of course, if you go up and then say, let's try on the first 1,000 tables. And I'm going to warm up the caches by using the parallel version, because that's nicer. So now we're doing 1,000 database calls, 7 seconds, it's 7 milliseconds per call. If we would do that sequentially, whoa. I would say 14 seconds. Do it in a parallel version. 3.8, right? Factor 4. And then you can say, well, Roger, which I'm very impressed about, he says he never wants to talk about improvements that's less than a factor of 10. But I mean, if we have critical parts of our code that can actually benefit for just cutting the execution time into a fourth. So in that sense, I think it's very easy. And well, I don't want to have these anymore, right? So I'm gonna disable them and gone there are, right? So what was the maintenance? What, just disable them, right? I need to do it again, right? Okay, then that's, and seriously, there is nothing in here that cannot be done in any other application. So this is my my approach to trying to get a troublesome, old-fashioned, hard-earning application to run a little bit faster. And I think you guys can actually do the same thing. Any questions? Gitte?
I'm just wondering why is the database faster just because it talks to 8 APL tasks instead of...
That is because Oracle is very good at handling multiple sessions at the same time. It can actually run in parallel. So what we have here is each of these guys here has a database connection. This is a full, all of these represents a full SimCorp Dimension application with their own database connection. So what Oracle is doing when I'm executing this in parallel, it's actually getting 7 calls in parallel from me. And because it's good at actually doing this in parallel, it can return in parallel as well.
So it's the database that's responding better to 7 tasks than to 1?
Yeah, but because when you do it here, it can only we can only call the database 1 at a time, because there's no way in the Dyalog APL we can actually get it to call the database more times.
Right. No, okay. No, that's brilliant.
But, and please don't, I mean, the reason why I'm using this is because it's very easy to explain what dbSelect does. But you can have any functionality packed into this.
Yeah, no, that's why I was wondering why this one in particular was the one you were showing, because it's a little bit counterintuitive actually, but it's a good thing to know. Thank you.
Yeah, this is very impressive. My question is, how do you handle error conditions? So something like, doing a count, you're pretty much guaranteed you're going to get some type of return. But what if that was a real select, selecting based on a certain query?
And then it would fail for some strange reason and give you an error.
Right. So if you've got the 8 nodes, would you get the results for,
There is, of course, error trapping in this. On these here, and this one I didn't show you here, but if you remember back, there was 3 elements coming back. There was a 0, which means the call was good. And there was a 1, returning 1 row and the number. So this one here will actually have an exit code that is different from 0 if one of these agents here is failing. And I don't think I have time to it, but I can actually, if you're interested, I can show you that we can go in here and we put a stop in dbSelect in one of the slaves here. And then you can actually go to that particular slave and debug it just like an ordinary session in here.
Okay, thank you.
Nice. As you point out, your different tasks are using very small CPU. You are exploiting the parallelism just in assessing Oracle. I don't know in which way you, are dealing with Oracle, but I'm thinking there was no way to obtain the same, just with the old APL threads and some way to have asynchronous access to Oracle, send the query and send many queries and wait the answer to come.
Yeah. You're probably right. One of the reasons why we have to do it like this, I mean, now we're talking dbSelect, but that is written in C++ and that's not thread safe, okay. The code in here. But if I'd call an APL function accessing a global variable or updating a global variable, that would not be thread safe neither. And then I actually have to go through all my code to assess that I are thread safe.
Okay.
Yeah, I think also in partial answer to that question, if you look at the fourth line on the screen now, it shows that the time in Oracle was about 1/3 of the total time, right? It was 100 milliseconds of CPU in APL and about 1.5 in total. Anyway, I just wanted to thank you really for the experience that you related earlier. The workshop that we ran on Sunday, SA2, I think it was, what was it called? Starting and Managing Processes, was really a course to teach people how to do this. You weren't there, I guess you figured out you already knew it. I think we're going to run that workshop again next year, because I agree with you, this is really useful, so thank you.
We're actually using the same technique for an actuarial company in Belgium, and we also found that it was very easy to change this. So you could actually run it on several machines and have the same principle because you're using Conga. And we actually have the same mechanism. We can actually run it on several machines as well as on a single core, like, some machine like this. It's the best way of doing it.
Yeah.
Just one more. I can see that this works well when you're running on a desktop machine and you've got 7 idle CPUs. What about when you start running in the cloud and you're paying for every watt of electricity used? Is it still a useful technique?
I would guess it would be, yes. The sum of the CPUs used is probably a little bit bigger, but I mean, I really don't know, but I'm assuming it's okay still. I have just one little thing here, and it's kind of like, wouldn't it be nice? To the left, you have C#. You have a piece of code reading lines from a file, and then you have the equivalent in APL, where you can say in C# for each, and then you do my stuff here. 2010, C# got this parallel for each. Wow, wouldn't it be nice if we had this one here? And I know there's all kinds of stuff that's hard to do in this, but I mean, if this is going to be a language where the domain user is doing stuff, right, you need to be able to do this. You cannot expect them to actually build an infrastructure with a lot of workspaces and a lot of Conga libraries and all this stuff. I'm working in a framework group where we can actually provide these stuff to our application developers, but I really don't want them to spend time building this themselves.
I'm not sure if Dyalog has put any constraints on the order of execution of each, or of the rank conjunction with the user-defined functions. In Sharp APL, we explicitly said that those types of constructs were, the order was fortuitous. So, in fact, if I said my stuff rank 0 and some array, those could be executed in parallel with no changes to user code.
No.
And so the only problem in doing this here is if my stuff has side effects, changing globals and things like that, where the results are unpredictable. As long as you require those to be strictly functional, then this is a perfectly safe thing to do today.
Yeah, but apart from not being executed in parallel.
Sort of what he addressed before. You've spun off a bunch of remote workspaces executing on remote cores, whether they're the cores on the chip or a core on another machine. But you've waited for everything to come back. Is there some way that you can queue this up so that if the remote machine or one of the cores is running slow, you can deal with some of what has been returned without having to wait for everything to be returned?
I mean, that would probably require us to be able to do futures for the results of these, right? And then you can say, okay, what futures are done now? And these futures will be the ones that we will executing on. But it is actually doing load balancing, and I didn't have time to show you yet. But one of the queries here is taking 3 seconds to execute. So there's one node that's only doing one query, and the other 7 is doing 999. I didn't show you yet, but it's... in total. Okay, I think I'm out of time.
Yep. Thank you very much, Lars.